We're doing video series here, and today we're going to be talking about flatness, but I'll remind you the 5 things we've been talking about over the last few weeks that we like to tell everybody who calls to help everybody out. And just a real easy way to remember things is right on your hand. We talk about sharp, set, flatness, roller guides, being in good shape, and the alignment of your wheels. Today we're going to be talking about flatness, and the flatness of your band blade itself. And the things that I'll tell you, this is something that we do for our customers already. When you're buying blades from us, if you have a problem or questions about these things, we train our people to understand about it, and if you have a deeper problem, then they can get to us and talk to us, and we'll do our best to help you understand that. And that's some of the value we add as we sell different products. But the bandsaw blade particularly, it can have something called anti-clastic curvature. That comes from running around a wheel. And I'm exaggerating this, but if your wheel is round like this, and you're turning, it is round like that, but according to the diameter of your wheel, if it's a 12-inch, it's small. If it's 19, a little bit larger. But if you take a straight edge, and a simple way to do this, Tim, my brother, talks about using a razor blade like for a box cutter. They're real cheap, just pennies, and you can lay that on top of this blade, and you can see if there's a curvature in it. And that affects your cutting. All those 5 things affect it, but this affects it quite a bit too. There's a long story behind how he figured this out, but we know 100% that this is true. And if you'll get a little razor blade, or if you have a little short straight edge, and this is just a little pocket rule that I like to use, you can lay that up there and you can see this for yourself. But when you're running around the wheel, you get what's a curvature. And the word we use is anti-clastic, came out of an old saw book somewhere one time. But when you bend this blade in this direction, I would ask you, and if you could answer me, I would imagine you would think that would curve downward like this. But the fact is it curves upward a little bit when you go around a wheel, or bend it in a circle like this. And when I lay that on there, I can see a little bit of light right in the center here. Now the funny thing is, if I turn it over and do it the other way, the same thing happens, and I see a little bit of light in the center instead of a hump. So it's really it's backwards to what you would normally think. Well, what that causes then is when you're running on a band wheel, you will find that doing that around the band wheel and straight, around the band wheel and straight, curving flat. Over time, it begins to develop that curvature and hold it. We say that stress builds up in the blade. It builds up on the tip of the tooth. It's getting duller from the beginning. The stress of cutting and friction is dulling the blade. Well, it's also building up in the body as this thing flexes around and around the wheel. And then when it comes out in the straightaway, after it's been flexing, it comes out straight, you begin to develop a curvature downward. And many times, more than not, if you're sawing, you'll see that blade tries to dive. Now, if you call us, we'll say, are you diving or rising in the cut? What's the first reaction? We've talked about that in a previous video. But what we're trying to figure out really is, do you have a curvature? Is it roller guides? The 5 things we're talking about, we're trying to determine what's happening. But this one is important enough, and we've done it enough time. And again, I'll tell you, get on your blade, bend the blade like this and check it. Get in the flat, or the straightaway we call it, and check it while it is tensioned up and see if you've got a curvature. And if you do, I don't even care if it's up. Sometimes blades come from the factory, and according to how they were treated in heat treatment, they may have a curve up to start with, and that thing may rise in the cut and you can't hold it down. But what we like to see actually is that we begin a little to the reverse of where it's going. In other words, it's going to ultimately end up curved down and try to go down. So we want to start with just a little bit of cup, and we're talking thousandths, y'all. We're not talking about, you're going to bend this and you're going to see a pure saucer there. You're looking at 2 or 3 thousandths. We're looking at a sheet of notebook paper, really. Thickness is that gap you'll see. So we like to start with that up and then roller guides we're going to get into next time, but so that we're running against our roller guide and it's coming up, we can control it. Because if my roller guides is up here and the curve is downward, then it's going to leave. It can leave. Or better yet, if I exaggerate that with my hand, just say this is my roller guide and I'm going to exaggerate. If there is a hump in the middle here and I'm only touching, the blade is touching here, then it can rock. It can rock. But if I'm cupped up the other way, then it's holding. It can hold it from coming up. Now if you do that too much, it'll come out of the cut anyway, or it'll make a round over on the log. But the flatness is just very critical. And again, it can come that way from the factory, or it can develop. It will develop, not can. It will develop. That's why if you got a little bitty 12-inch wheel, I've seen some of those from time to time, it's going to develop curvature quicker than a larger 26-inch diameter wheel. So the larger the wheel, the better off you are. Even larger than that helps with this. It slows that down. So that's important as well. It also, large wheel size, lessens the amount of bend, which can give you a little bit better blade life as well. But we have machinery here that we can correct this. And as you buy things from us, if you can talk to us and tell us what, notice real critically what the blade is doing, we can tailor fit this to your machine, to your sawmill. And I tell people, every sawmill is different. A lot of times these things are being custom made, and even if they're not, they're being put together on assembly lines or by different people, and something can be a little bit different in every machine. And so these are the 5 things. We've got 2 more to do: the rollers and vertical alignment of the wheels. But this is a critical one. And as you buy things from us, if you'll talk to us and help us understand that, then we will try and can tailor fit blades for your specific machine and make notes and make that work better for you. So I think that's a very important lesson here today is to check that flatness, and you can check it for yourself and see what you see on your mill, and it'll help you out.